Hello everybody, well, good morning again. Hello, it's morning for me here, so good morning to you everybody, and I hope you have a nice day. Well chaps, I promised you I would start off the recapping of this receiver, and that's exactly what we're going to do, but it's not the only thing we have to do, unfortunately. I picked a little coil up that isn't supposed to be in here. That's the first thing what I have to say. There's a resistor coupled to it, and it's coupled to the anode of, let's have a look, the SG7, and well, the other point is I tested this coil. It looks very impressive. The coil is open. Yes, you hear that right. The coil is open. I didn't touch him at all. Just got them out and then had a test with the ohm meter, and he's open. And I checked here, and the wire hanging off somewhere here. So somebody put that in there. But probably, well, this will work. No, won't. So. This little resistor here is a 1K resistor. It's the wrong resistor. It should be a 22 ohms resistor. Even if there's even soldering there, this is a wrong resistor. It should be 22. Now we have a laugh. We have here this resistor that was connected to that coil. We have here a micro capacitor to the switch. And if I look at my schematic, there should be a 22 ohms resistor to pin 22 on the switch. We have here a capacitor. It's the anode. That should the voltage should go straight to the valve via this switch to there on this 0.8 of the anode. No way. A capacitor doesn't conduct DC. So the little chap put that in there and it didn't work. Absolutely chaps, it is a disaster. You've been on all over it. Well, stop moaning and start working. We have here the first valve, that is the RF amplification valve. That's the way it's going to work. Then we go over to the mixer and oscillator. From the oscillator via this coil to the first SK6 SK7, yeah. From this coil, you can see that, yeah, still. We go to the next SK7, this next to it here. You can see it, yeah. Then we go to this coil. We go to the, have a look. That should be what? Have a look. Now the next valve, put it that way. There's another SK7, there's 3 of them. SK7, no, two of them. Sorry, my fault, my mistake. Then we have the next valve is the SK7, and well, I can't make it out here. That's the next valve, and the next valve, and the end valve. So. 4 valves, that's the way it's going to work. So go that way, goes a single, that way down here, to that coil, and up to via that coil. You can't see that, no, nearly not. Lift it up a bit. There we go. And see if I can refocus. That's not very sharp, is it? We have this coil here. I have the coil out of this from the SK7 is the SG6XQ7. Anyway, this is how the signal is running. Do that valve, until that valve. Okay, that's the way it's going to go. That's the way I'm going to do this. And by Turn it around that way again, put it down. That's the way it's going to be. So I go up here from this valve to the next one. Oh, I have to focus here again. Okay, do that. Up to that valve on top. You can't see it. There we go. To that valve. We have to check this out completely, because this whole coil box is involved. That's the whole coil box is involved in this. So I have to be absolutely sure this is all correct. Mind you, we have to realign them, that's for sure. So, but the realignment will start off with the EF cans. So we have to put that right first, so that is okay. So we get the signal through to the end. So enough babbling, and I'll start this off. I'll start off in the first valve, and I will check on the schematic if everything is okay. We have here still a wire hanging around. That's wrong too, you know. He goes straight to ground, and it shouldn't be on to ground. Of course, according to schematic, it's go to one point of a switch. This one and this point of this coil are together, connected together, and this little wire should go to a switch, not to the to ground. I've discovered another few things. Now you can see, perhaps I'm babbling a lot, but you can see what I meant with don't plug this thing in when you get them. Now you know why. You don't have to plug that thing in. If you do that, fortunately, I must say this, fortunately, the mistakes wouldn't be fatal. They all go to ground, the mistakes, or there is no voltage or whatever. The other mistakes you can have any consequences on the valve. But if that is wrongly wired and it is high voltage involved and goes on one of the grids, you can forget that valve. It just blows up, that's it. So, not chatting, I'm going to shut the camera down. I'm going to get this capacitor out, that capacitor out, get that resistor replaced, get this rubbish out, and see what else is all wrong here, so that we have the right thing to start off with. I really don't trust anything anymore, because I don't know, we will see. Okay, I'll come back to you. Welcome back. I'll tell you the truth. It took me up to 3 hours to sort this thing out here. Yeah, 3 hours, yes, because I didn't know what is going on. So I have to recheck everything down here, how it is connected up, and so on and so on. But after a little while, you know, that wire was stuck up here. I came to the conclusion that this wire was cut, and he belongs here on this point. And so I put a new wire in. This resistor that I said should be replaced, I didn't replace that one. I measured him, he was 22 ohms, so he is okay. I replaced another 22 ohm in there. There was this capacitor in place of that. See what you can see. This capacitor is 137 picofarads. It's a marker capacitor. I didn't test him properly if he's okay, so I don't know. And I took those capacitors out. So well, we won't go for the leak test, but you know they are leaky. And that's that. So the next thing to do is to go to a mixer oscillator tube, valve. I say tube, that's American. We have to check this circuit out as well. That takes a little while. There are some capacitors here. This one and this one has to go. This 10k resistor, I will replace that as well. I don't trust that either. One of the old ones. So we can take no chances, I'll take him out. I will check everything here. This core here is very battered, as well as in the one in the corner. Yeah, you had some screwing down there. Oh, hopefully it will tune off later on. Well, that's the consequence when somebody's on there, he doesn't know what he's doing. So I'll really get upset about those things. Well, my heart is in this receiver, and I just can't understand how people say, oh, I can do that. I'll keep on about it. Oh, anyways, we have to have a go at this valve. We will replace those 3 parts. I will check the wiring, see if something is not as it should, so I suppose it will be okay. The only thing I discovered is this capacitor here is a microcapacitor. I thought, first of all, well, there's a resistor, but it's not. There's a ceramic capacitor, not a ceramic capacitor. So he has this value. Keep an eye on that one. So if something is not right in this circuit, I will replace this one first. So that's that. So I will carry on and I'll see you in a moment. Righty ho, we're back again. Well, I have good news. This costed me only about half an hour. So I replaced the capacitors. You see, I learned that from Mr. Carlton. Put a dot on there where you know what, yeah? But the ground is or whatever, but your fingers have the least influence. So that's what we done with this one. Paul is always very particular about those things, and he's right though, it's absolutely right. Anyway, I replaced this 10K as I said, and believe me, he was out of tolerance. Well, those resistors are notorious of getting out of tolerance. He was 13K instead of 10, so I put the new one in. It's a 1 watt type. I suspect that bigness is not due to the voltage what you can have, but I see something flashing here. I think my battery is nearly empty. Well, I have to go on with it. So yeah, I think the size of that resistor is not the voltage what it really is. I think at 1 watt, see what the difference of size. So I checked this wiring all together, and that seems to work out. So that's from crime to me. I have my lamp in a minute. Obviously I missed something here. I'll see if I'm right or wrong. No, I'm wrong. But then again I have to check him anyway, so that's a good, it should be 20 watts, I don't know. I will check him if he's out of tolerance, he goes. And this resistor here, I meant that one. So anyway chaps, we're making progress. The next thing we're going to do is going to this valve. I can't see that, do you? I'll show you. Hold on. Oops, okay. I'll focus. I'll go to this valve. Here's a lot of stuff in there. So see the way we go up and then we come down, and so we go through this, and everything that is this one here is very peculiar. It shouldn't be there. I didn't saw him on the schematic, so this probably has to go for some reason. I have to check this all out again. What I also notice is that when flattened all the contacts on the sockets, and they are very brittle, so if you're not careful they will break off, and then you can put in new sockets, and then it won't be original anymore. So anyway, so far so good, and we go on with that one. I'll see you in a minute. Guys, welcome back. Oh, there we are, and I had to look up some expressions here on the valves, so we have the proper name. So, well, I want to show you something here, and I'll take it all. You have to know this. This guy what we've been working with did a real number on this radio. This lead here comes from the IF can and comes to here pin 3, and if I write here pin 3 is the suppressor grid. I thought, yeah, that is the suppressor grid. So we connected the coil wrongly to the suppressor grid. It should be on 4. And I have here number 1, that's ground. Then you have the filaments 2, the suppressor grid and steering grid. That's how we call it, eh? Or grid, just normal grid. Let's have a look. Control grid you call it, okay. That's the control grid where the signal comes in. Yeah. Look what he has done. He has connected the filament to the control grid. So absolutely stupid. There were 2 capacitors here. One capacitor to the cathode. Yeah, that was an 0.05. And I have another one 0.05 here. Was connected to 4. The control grid. I don't know why. And he had another couple of resistors here hanging around. That doesn't make sense, so I got them out. I have here a wire that's been cut off. I don't know why, you tell me. So what I have to do now is to get everything right. Get number 3, this one here, onto the cathode, as it should. Yeah, and disconnected. You connect this to ground. Get a capacitor in from here to ground. Yeah, and then we have to see where the other cap is coming from. I don't know. It's absolutely mysterious what he's all done. I don't know exactly what he's all been up to, but there we go. There is only 2 capacitors for this valve. There's one capacitor on the cathode and one capacitor on the back lead, or the feeding lead from the IF can, which comes up here. Can you see it? No, you can't see that, good. I'm telling you something, you can't even see it. Oh, how silly. I'll zoom out a little bit. Oh, okay. Let's just refocus. That's okay. Now this is the lead what I'm running out about. So this lead, what is on the up here, this black lead, comes up to this point, and that's where the voltage is coming from. Yeah, and that's decoupled with this capacitor, an O2 capacitor. So I really don't know where that second capacitor was coming from. I'm absolutely flabbergasted where that's coming from. So I have to check the whole shebang to see if everything is as it should be. To a certain extent everything should be on its place, but you never know, because I can't really tell what has been done to the radio. You got this as quite a time back is that done to the radio, so you can't see on the soldering points, you can't see if they've been worked on. Normally you can see that. At this point, I figure it will be further back than I think, a couple of years, even perhaps 10 years ago. So everything is normally oxidized and you can't see that anymore. So, having said all this, so I have to get this right, get 2 onto the on ground. The chassis is that here. So there's even a thin lead. I absolutely don't know what is going on here. So I have to figure it all out. So this is 2 is the filament. So I don't know how we got to getting this onto 0.4. I really don't get it. I really don't get it. Absolutely, I don't get it. Anyway, so gentlemen, I'll proceed and correct all this. I will go with a fine tooth comb through this to find out what's going on. So Paul would say, well, I'll rip it all apart and start all over. Well, there's an idea. But there again, it won't be me that original anymore. So on the other hand, is it so I'll have to struggle along, and hopefully can find everything which is done to it. Honestly, here on this part, here, I'm sorry about it. Here in this part, I don't believe anything will be right. Honestly, this doesn't belong here. What this is, I don't know. Well, I will go this way, and the next one will be this point, this can, and we go over to that one. Yeah, and then there's the second 6 SK7. So I have to see that those resistors will leave, because they will be absolutely out of tolerance. I had to check on the signal meter, because the socket is here. I had to check that out, the number 2 of this lead. I checked that out, that did work out. So anyways, you have to go carefully, step by step, go through this and find out what's going on. So as soon as I've done this, I will be back. Oh chaps, I'm back again. So you can see I disconnected the AF can, and according to the plan, I was cleaning up all the contacts on the valve. Here, 1, 2, just connected up to ground, disconnected them, and I was cleaning up contact 4, and it broke off. There you go. It broke off, and the contacts are so brittle. I decided to remove that socket. I'm not going to keep on this. I will carefully drill this out, move it aside, get this capacitor off, and this resistor, well, not really, and then I will check the wiring. This is also stupid. This is also short. It's been on here as well. So all the string was around the cable is gone. You remove that as well. So I have to do it all, so you know. I'm going to put this in this socket, this one here, and then we see how we go. Okay, I'll come back to you. Okay, well, as you can see, I replaced the socket, the valve socket, and I had a check, small check. What I'm going to do now is to recheck all the parts here up to here, come back, have a look at this part here, because I don't believe this wire is right. Something is fishy about this. I don't believe in this, because it is very, very strange. It's connected to electrolytic capacitor. I don't trust this, because it's just put in there. So what I'm going to do first is to check all the schematic up to here. I still miss that capacitor where he's have to go. So I have to recheck it all. Also, what I saw that there's been a screen on top of the IF cans, and probably they are removed. Well, that's not a big problem. So I can, with some aluminum sheet, I can make those little things and put them on there. But I won't do that immediately. I'll tell you why. I will try that radio first, and then see if there's any influence on it. If it has, I'll cover them up, so that is not a big problem. So, but there again, it is the tricky part is now to see if everything is wired up correctly. And that will take some time to do this. Anyway, chaps, I will conclude this part because of the video length and time, and I'll come back to you with a new part, and then we just proceed from this point on to go further on to the next SK6, SK7 up to the 6H6 to the blah, blah, blah. Have a look. My memory is not that good. This is the 6XQ7. There's that one here, and then there's a couple of valves here. So you have to check that power supply out as well. So yeah, I think a couple of videos and we are there. I will make sure, I'm absolutely sure everything is wired up correctly. So to have no nasty surprises when we power this thing up. How I'm going to do this is the following: is I will leave all the valves out, put them on the side, leave all the valves out, have via my protection transformer, I will power them up slowly with the variac, see we do the smoke test if you will, and then we have to put the end valve in, and then we check if the end valve gives a signal if I go on the grid. If it does, then you can put the next valve in, so check that as well, and so on and so on, until we get behind here on the oscillator mixer valve. There we want to put a signal in from 455 kilohertz, and then we will adjust the IF cans, and if that is all properly done, then we have the normal tone. Then we proceed with the rest of the radio. Then we plug all the mixer tube in, and we plug the RF tube in, and then we see if we can get a signal out of it. I doubt it, but then we will try, and if that is not working, then we start from band 1, the lowest band, because he will pull the hardest on the oscillator, so we do that first. Realign that one, and then go to the next band and the next band and the back band, and then we have a working radio. Well, that's fast, isn't it? That's very fast. And I never imagined that I did it in 4 videos. No, I'm joking, but yeah, I'm eager to get this thing running. Actually, I can't wait a bit. Anyway, I'm a bit tired now, and all I'm going to do is put this video onto the channel, and then tomorrow I will proceed with the next, because if you're tired, and then you should stop working on the radio, because you're going to make mistakes, and then you have one mistake in the other. That's not what you want. So, and anyway, gentlemen, if you like my video and if you like my chats, then give me a thumbs up, and then we'll see you next time. All right.